Hey, welcome to day 13. It's technically past my bedtime, but I'm trying to sleep less and get more done. So, in the interest of sleeping less and getting more done, I'm going to start recording past my bedtime. And hopefully that won't stop me from getting the right answer. So, day, um, day 13. You need to cross a vast firewall. The firewall consists of several layers, each with a security scanner that moves back and forth across the layer. To succeed, you must not be detected by a scanner. By studying the firewall briefly, you're able to record in your puzzle input the depth of each layer and the range of the scanning area for the scanner within it, written as depth:range. Each layer is a thickness of exactly 1. Layer depth 0 begins immediately inside the firewall. Layer depth 1 will start immediately after that. For example, suppose you've recorded the following. Depth 0, range 3, depth 1, range 4, depth 4, range 4, depth 6, range 4. That means there's a layer immediately inside the firewall with range 3. Second layer immediately after that with range 2. A third layer which begins at depth 4 with range 4. And a fourth layer which begins at depth 6 also with range 4. Okay, so visually it looks like this. Within each layer, a security scanner moves back and forth within its range. Each security scanner starts at the top. So a layer is a column. Each security scanner starts on, moves down till it reaches the bottom, and then moves up till it reaches the top and repeats. Security scanner takes 1 picosecond to move 1 step. Drawing scanner says as the first few picoseconds look like this. Picosecond 1, picosecond 2, picosecond 3. Your plan is to hitch a ride on a packet about to move through the firewall. The packet will travel along the top of each layer, and it moves at 1 layer per picosecond. Each picosecond, the packet moves 1 layer forward. Its first move takes it into layer 0, and then the scanners move 1 step. If there's a scanner at the top of the layer as your packet enters it, you are caught. The scanner moves into the top of its layer while you are there. You are not caught. It doesn't have time to notice you before you leave. You do this in the variation above, marking your current position with parentheses. Passage through the firewall would look like this. So move in, these guys down, move over. He goes up and catches you, I guess. I think he would catch you. You're caught in layers 0 and right. You're caught in layers 0 and 6 as your packet entered the layer when its scanner was at the top when you entered it. You're not caught in layer 1. The severity of getting caught in layers is equal to its depth multiplied by its range. Ignore layers in which you do not get caught. The severity of the whole trip is the sum of those values. In the example above, the trip severity is 0 times 3 plus 6 times 4 equals 24. Given the details of the firewall you've recorded, if you leave immediately, what is the severity of your whole trip? Okay. So, day 13 firewall. Day 13 firewall.py. And, as always, I will copy this. And this is one of those things where it seems complicated, but it's probably not that hard if we think about it. So let's get the test input. Test input equals this. And, let's def process line is a string, and it's going to go to, I'll just do a tuple int, and which means that from typing import tuple, and this will be an easy one to do because all I want to do is say, and what do I call this? Depth and range. Depth, range. I'm going to put an underscore there because range is a built-in word and I don't like redefining built-in words. It causes problems. Depth range equals line dot split on colon, and then just return int depth int range. And so let's think about this. You know what? I'm gonna make Yeah, that's fine. What am I calling these things? A layer. So let me do the following actually. So let's do a layer which is a named tuple subclass, and so I'll import named tuple, and we'll say that a layer has two things. It has a range, which is an int, and it also has scanner. It has a scanner, which is an int, which starts at 0. So I said I didn't like to redefine this, but I did redefine it. I think this is. I'm just going to call this rang, which is bad, but you know what I mean. And we will do a tuple int layer, and now something like this. Okay, so what don't you like? So assert the process line of, and let's do 6, 4 equals, and what does it equal? It equals 6, comma, layer 4. So let's start IPython and zoom in a little bit because we can. And let's run day 13 firewall.py and then assert passed. So that is good. Okay, so now what do we want to do? We want to say, how do we want to represent this? We want to represent this as a dictionary from, let's call this a firewall. So def, firewall, let's get firewall, and it will get some, let's call it firewall. No, I'll call it get firewall. I'm pretty indecisive here this late at night. And I have some text, and it will be a dictionary from an int to a layer. And what I will do is I will say firewall is a dict from int to layer, and that equals empty for line in s.split on new lines. Okay, and what I want to do is I want to say depth layer equals process line, and then firewall depth equals layer. And so let's just print get firewall of, what do I call it? Test input. And let's run this. Error dict is not defined. Okay, that's easy enough to fix. Did I not return something? I did not return something. Return firewall. Now let's try it one more time. So 0 goes to range 3 and scanner 0. Scanner 0. And you know what? Now, along with the scanner, I need to have a direction, and I'll just call that scanner down is a bool, and that equals true. And now, can we ever have a layer of depth 1? We cannot, so I won't worry about that case. And so what do I want to do? I want to, let's say, I'll call this a step, which takes And I'm going to do something sort of silly here. No, I'm not. I was going to define a type alias for dict int layer. So dict int layer, and this will be a firewall. And it's also going to return like basically the next step of the firewall, right? So let me do next layer, layer, takes a layer. And so, you know, so let's say if layer dot scanner down. So if it's going down, and two things can happen. If layer dot scanner equals layer dot depth -1. So it's going down, but it's already basically at the bottom. Then scanner down equals false. Scanner minus equals 1. Otherwise, scanner plus equals 1. And then otherwise, we're going, excuse me, otherwise we're going up. And so then what we're going to do is if layer.scanner equals 0, then we can't actually go up. Scanner down equals true. And actually, because we're doing this in an immutable way, I need to do scanner down equals true. So go scanner down equals true, scanner plus equals 1. Otherwise, we're not at the top, so scanner down equals false, and scanner minus equals 1. And I'm just going to return a layer of layer dot depth scanner down. And let's just try this out. So let me say test firewall equals get firewall test input instead of printing it. And now, you know, we have this 0, 3. So let's say layer equals test firewall 0. And, you know, for, let's just do 10 steps. Print layer equals, and what did I call it? Next layer. So what happens if I run this? Let's make sure it's layer has no attribute depth. It's called ring. I'm going to regret naming it that because ring. Okay. Try this again. Little variable scanner reference before assignment. What line is this? Right. So scanner equals layer.scanner, and now I can subtract from it and do that. Okay, so scanner 0, 1, 2, down is true, 1, 0, 1, 2, 1, 0, 1. So 0, 1, 2, 1, 0. So that seems right. 0, 1, 2, 1, 0, 1, 2, 1, 0. Okay, and let's just try one more. And so, you know, let's try 4 and just do actually 20 of these and see if it's doing the right thing. So we start with 4, it starts at 0, 1, 2, 3, and then 2, 1, 0, 1, 2, 3. And I think that's how we said it would work, right? So 0, 1, 2, 1. This one goes 0. Okay, so that seems good. And now we're going to move 1 layer per picosecond. Well, okay, so now we want to, this is real easy. We will just say return depth next layer for depth layer in firewall.items. And we can again do a little test for something in range 10. Let's say firewall equals test firewall, print firewall, firewall equals step firewall. Okay. So let's see if we can make sense of this. This guy's going 0, 1, 2, 1, 0. This guy has a range 2, so he goes 0, 1, 0, 1, 0, 1. This guy has range 4, so he'll go 0, 1, 2, 3, 2, 1. So that seems to be doing the right thing. Good. And now let's just go back and see what do we need to do. Your plan is to ride in a packet. So if there is a scanner at the top of the layer, as your packet enters it, you are caught. If a scanner moves into the top of its layer there, you're not caught. If you're to do this, and severity of the whole trip. Okay, good. So let's try this. Def of severity, and I think all we need is a firewall, which is a dict of int to layer. And we have, num layers equals, let's just say max layer equals max of firewall. I'm not doing the max over the keys. And so for something, call it I, in range max layer plus, we got to do max layer plus 1, right? Because here when the biggest is 6, we actually need to step. We need to do range 7. So what do I want to do? And now here is it's actually the depth. So enter the layer when the scanner's at the top when you enter it. So it's bad if okay, so let's just say the layer equals firewall dot get depth. If layer and layer dot what do I want to do? Layer dot what do I call it? Scanner equals 0. So this is the bad case. Caught. Total severity equals 0. Total severity plus equals, and we said we want to add depth multiplied by its range. So plus equals depth times layer dot rang, which is unfortunate. And now I'm going to say firewall equals step firewall. Okay, and then I want to return total severity. And now let's print total severity of test firewall. And according to their thing, it should be 24. And you know what? Let's just say print caught depth layer. So that should be pretty good. Name total severity is not defined. Oh, because that's not the name of the function. The function is just called severity. So we're caught in 0, range is 3, and then we're caught in 6, range is 4, and we get a total of 24. So that seems right. So what is the severity of your whole trip? Okay. So let's try it. Day 13 input.text. And so now if name equals main with open day 13 input.text as f firewall equals get firewall f.read and then print severity of the firewall. So that should be what we need to do. Not enough values to unpack. So why would that be the case? Did I get a blank line at the end or something? Let's figure out why this did not go so well. Print line. Is there just a blank line at the end? Is that the problem? If not line, continue. See if that makes a difference. Okay, so caught in 0. In 6 we have a layer which is range 4, so that means it'll go 0, 1, 2, 3, 2, 1, 0, because that'll be actually in the 7th step. And then in the 10th, in the 11th step, we'll get the 6 coming back. In the 22nd, 23rd step, we'll get this coming back. In the 29th step, we'll get 8 coming back, 76. Seems reasonable enough. Let's try it. 3184. That's the right answer. Okay, good. So let's return to day 13. Now you need to pass through the firewall without being caught. Easier said than done. You can't control the speed of the packet, but you can delay it any number of picoseconds. For each picosecond you delay the packet before beginning your trip, all security standards move one step. You're not in the firewall during this time. You don't enter layer 0 until you stop delaying the packet. Example above, if you delay 10 picoseconds, you won't get caught. Because all smaller delays, what is the fewest number of picoseconds you need to delay the packet to pass through the firewall without being caught? Okay. Well, there's a real easy brute force way to do this, and let's do the following. So let's just copy this function and we'll just say, are you caught? And that's going to be a bool. And what I will do is I'll just say if layer, and so then we'll return true that you were caught. And print this, and then if you didn't get caught, we'll do that, and if you never got caught, we'll return false. So that's easy enough. So let's just print caught firewall, and there you're caught at 0. I did this earlier. I'm going to do from iter tools import count. Count will just give me let's like try waiting. So for wait in, actually I don't like doing, I'm just going to do import iter tools, because count is a variable that gets thrown around a lot, so I don't like to use it bare. So iter tools.count, and starts at 0 and it goes off by 1, so that's good. And now we shouldn't be touching the firewall, right? Because when I did severity, I'm not modifying firewall. I'm not modifying firewall. So, and let me write a function so I can test it. So def min wait for some firewall, which is a dictionary, from int to layer. And so what I want to do is for wait in iter tools.count, so that'll be 0, 1, 2, whatever. Let's say print wait. If not caught firewall, return wait. Otherwise, firewall equals step firewall, and so let's just print min wait of test firewall and see what happens there. And let me comment this out because I don't want to see it. And it's saying that 10 is the first one we don't get caught, which was the right answer, so that seems pretty good. And I'll just change that to an assert. Print min wait firewall, and now let's run it and see what happens. Woo. So there's probably I don't want to print all these. I'm going to comment out the prints. And what else was it printing? It's printing wait, and then it print caught one layer. So that means there's a print in caught. So I want to comment that out too. It will run much faster without that. Oh, whoops. Why did it keep going? Why does it have those cots in there? Take out all my prints. Oh, that 3184 is the severity of the first one, that's why. So this might run for a long time, in which case I need to come up with a better solution. So let's think about what that better solution might be. Some kind of funny Chinese remainder thing, maybe. So, all smaller delays would get you caught. Okay, well, if nothing else, let's so let me change the way I'm doing min weight, because I think this is a bad way to do it. So I'm just going to comment these out for a second, because I think I'm basically doing like a really inefficient amount of work. So let's rewrite min weight for a firewall dict int layer. Okay, and so so what I want to do is I want to and so let's say max layer equals max firewall, and let's say states equals firewall, and for something in range max layer firewall equals step firewall, and states dot append firewall. And you know what, I'm going to want to pop these off. So from collections import double-ended queue, and I've lost my function. So I'll say states equals double-ended queue of firewall, and then I think I can do say from collections import dec x equals dec 1 2 3 x. Can I do it like that? Yeah. Okay, good. So states equals dec firewall, and for this in range max layer states dot append. I'm just going to do step of states minus 1. So that's real easy. So you know, at this point we have the first in states, or the first max layer plus 1 states, sorry, max layer plus 1 states. And what we want to do is basically we need to for weight in itertools.count, and now we want to wait for safe. Safe equals not, I'll just write unsafe equals any state dot, what did I call it? Scanner. Dot scanner equals 0. Any state and state dot scanner equals 0. Actually, let me write this. No, so what do I want to do? What I want to do is say, I want 0 from the first, 1 from the second, checks equals, for wait intertools count. So now what do I want to do? Safe equals true for I in range max layer plus 1. Layer equals states I dot get I. Let's see if this is right. I could be screwing this up big. And if layer and layer dot scanner equals 0, safe equals false, and break if safe return wait. So let me run this and see if it passes even my test, which it probably won't. Oh, maybe it will. Otherwise, what I want to do, and I want to do states.append again step states -1, and then also states.pop left, so we throw that away. Now let's try this again. And now it seems to have worked, which is good. So let's try doing this. And it's still going to be super slow. So let me print wait. Okay, so that worked. And now, okay, so if this brute force thing doesn't work, we're going to have to try and be more clever. So while that runs, let's think about how to be more clever. We just let it run for a long time. Fewest number of picoseconds needed to delay the packet without getting caught. Okay, so let's think about this. So 0, So let's try and be clever. 0 has 3, so it will go 0, 1, 2, 1, 0. So we're basically, we're bad at time 0, we're bad at time 5. So this is not going well. So let's comment this one out as well, and try a third approach, which is fine. It's going to be a long video, but so we have a firewall, which is a dict from int to layer, and it will return an int, and so it's pass. So let's def valid times to visit. Let's say depth, which is an int, and actually we don't need depth, we just need valid times to visit a layer. And rather than say valid times, let's say bad times, which is the layer, which is the layer. And so, you know, if a layer has range 3, it will go 0, 1, 2, 1, 0, 1, 2, 1, 0. So its bad times are 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. If a layer has range 2, it will go 0, 1, 0, 1, 0, 1. So its bad times are 0, 2, 4. If a layer has range 4, it will go 0, 1, 2, 3, 2, 1, 0. So its bad times are 0, 1, 2, 3, 4, 5, 6, 12, etc. So return itertools. So let's say step equals layer.rang. And so what are we doing? We're basically subtracting 1 and multiplying by 2. Layer.rang minus 1 times 2, right? So if I have range 2, I subtract off 1, and then it's bad every 2. If I have 3, I subtract off 1, multiply by 2, and it's every 4. Start equals 0, step equals step. Okay, so this is just going to give me the bad times for a layer. And so what are we going to do? And is this thing, I should have just let it run while I think about this. So, how long have I been recording for? 45 minutes, and I'm not close to getting finished. Okay, good. So, you know, what am I trying to do here? I'm trying to say that, you know, 50 will be bad at 0, and 22, and so on. So that means I need to delay so let me think about this. You know, is um, uh, is good weight if I have some depth, which is an int, and a layer, which is a layer, and some weight, which is an int, and that's a bool. So let's think about this. Is it a good weight? So this is bad every, so let's say, and I'm getting too tired to not call this rang equals layer dot rang minus 1 times 2. And so what do I want to do? And so it's a good weight if it doesn't get here. So this is the step, right? If it doesn't get here at a multiple of step, so get here at, weight plus depth. And so we want to return get here at, and we want that to be not a multiple of step not equal to 0. And this is, is good weight for layer. And let's say is good weight for a firewall, which is a dict of int to layer, and a weight, which is an int, and that will be a bool. And it's a good weight if it's a good weight for every single one of these. So for depth layer in firewall.items, if not is good weight for layer, depth layer weight, return false, otherwise return true. And now for this min weight, we'll just say for weight in itertools.count, print weight, and if is good weight, firewall and weight, return weight. So let's run this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's much simpler than the previous one, and it seems to have worked. So let's try it. It's definitely going a lot faster. And let's not, if I don't print them all, it will go even faster still. So, if weight mod 10,000 equals 0, print weight. So that way we'll get some notion of progress, but not too much. and this one finally spits it out. So let's try it. 3878062. That's the right answer. 1 gold star closer to. Okay, so that was an interesting one because, you know, so what did I say the answer was? That was 3,800,000. So if I had gone with my original one and just said weight mod 10,000 equals 0, how long would it have taken me to get to 3.8 million? Name caught is not defined. So I guess I better undo this one too. $40, $50. So yeah, this one would take quite a while. Okay, so you know, it actually would have worked if I would have just let it run for a long time, but I did not let it run for a long time, and so it did not work. So anyway, that was interesting in that we tried several different approaches to the problem. One was brute force, and another one was also brute force, and then finally we sat down and just tried to puzzle it out more simply, and it worked. So cool. That was a little bit of a mess, but hopefully it was valuable and we all learned something, and I'm mostly just happy that I got the problem solved and I can go to sleep. So thanks for watching. As always, you can find me on Twitter at Grus, and I will see you next time. Good night.